Good morning, everyone. My name is Dale Lutz.
And I'm Lena,
and we're excited to be showing you a number of different scenarios involving working with Autodesk products and the data they create today. We're both from SAFE Software. SAFE makes a product called FME, or Feature Manipulation Engine, that's been around for 23 years. Nearly at the very beginning, almost the fourth or fifth thing we did was support DWG and DXF as a file format, and it's sure come a long ways. We've titled this that AutoCAD to GIS is only the beginning, and that was really the beginning where we started. All those years ago, people wanted to go from CAD data to GIS, but actually, Lena, they also wanted to go from GIS back to CAD. And so today, are you going to show us some of that stuff?
Yes, we will take a look at both scenarios.
Yes. So we're delighted to have you with us. It's a beautiful, clear, crisp day in Vancouver. This is where the weather snobs of Vancouver like to say, it's so cold and miserable. How cold was it this morning, Lena?
Oh, it was -1.
Okay, and so nearly the office is shut down because we don't know what to do. Apologies to just about everyone else in North America and Europe at our wimpiness. So FME is a product that sits in the middle between all kinds of different products and data formats and systems, and allows us to move data around. And while it's moving around, we can do all kinds of interesting things to that data. So there's both a transformation aspect and a data movement aspect. And lastly, there's also an automation aspect. And during the next hour or so that we have together, we'll show you a number of these types of things that we hope can add tremendous value and productivity to your workflows in your workplaces. And the key thing is, as this slide highlights, all of this is done without actually writing any code. It's all an environment that we provide where you can configure it and set up rules to do what you need to do. So in terms of the products that FME supports in the Autodesk realm, it's quite a number. Of course, we've always supported AutoCAD almost since the beginning, the DWG side of things. Civil 3D, I was talking to Regan, who's actually joined us today, our lead CAD developer and team leader, and he said it was about 2009 when we began our journey to read the Civil 3D objects, and we'll take a peek at later on at how some of our customers are doing things with that. Map 3D, we've done a thorough job of that now for years and years, reading and writing object data in very powerful ways. Revit, I think we're more near the beginning of our journey there. We'll take a peek at that near the end of our time today, but we can definitely extract data from Revit files. There's a little bit of a dance you have to do that. And the most recent member in this quintuplet set is BIM 360, and we'll talk a bit about our support of that. Now, Lena and I were just at Autodesk University. I didn't actually talk to you ahead of time, but Lena, if I was to ask you what's your one memory or what's your one impression of your first ever Autodesk University, what would it be?
It was really fun and inspiring. Inspiring is probably the key word.
Yes. Yeah, to see a $3 billion a year company innovating and changing as quickly as they do, and frankly to see the logistics in place that make a comfortable and well-organized experience for almost 15,000 people.
That was awesome.
Yeah, it was impressive. And as my friend Don would say, it was in Vegas, and so that, how could it go wrong based on that? But the key thing that SAFE took away from that was the details around the Forge API, the fundamental building blocks of Autodesk's new web platforms that allow third-party developers such as us to leverage the infrastructure that Autodesk is creating as they transition into a hybrid world where some work happens on the desktop and a lot of work happens on the cloud. And that transition is happening rapidly right underneath our noses. And so we're excited to show, actually to kick off this webinar, a little demonstration related to that. So some people talk about A360. There's been a little bit of branding transition happening at Autodesk over the last little while. A360 or Autodesk 360 was the name that was used for kind of a collaborative file sharing and viewing and infrastructure, kind of like Dropbox on steroids for design data. But more recently, they've branded into two things, BIM 360 and Fusion 360, which are really just sub-dialects of the old A360. And so BIM 360 team is really the Dropbox on steroids that allows files to be uploaded and worked with and collaborated upon within a BIM type context. And that's closest to where our audience and most of you, I suspect, sit. Fusion 360 is more for actually the manufacturing side of things, not so much where SAFE plays. And so we'll take a quick peek at that. So let's imagine a problem, and this is a somewhat synthetically created problem, where we want to automate building footprint extrusion and upload that to BIM 360. So the idea is that Lena's gone away and she's made me a CAD file of a proposed theater that we want to build, and she's put it up in BIM 360. And so I'm going to just, whoops, yeah, let's go like that, and let's take a peek. Not so much here. All right, so how about here? Maybe I have to end the presentation. I need to go into BIM 360 here, and I've taken, I've got my an account that I made recently, and I've got this theater project that Lena and I are collaborating on. And so she's got a building footprint there for me in a DWG file. And so part of BIM 360 is a really fancy viewer. And let's look, and this, what an exciting, you've spent a lot of time drawing this. Yeah,
and
so
it's a theater, so it has to be exciting.
Yeah, it's very exciting. Look, I can move it around. How much greater could it get? So to get a little different idea at this, I'm going to start up FME and take a look at this thing. Okay, so here is my, let me just knock this down a shade so you can see it. So what I'm going to do is read that file, and it happens to have extended entity data in it that Lena put the height into. And so we're extracting that automatically. There's a whole host of ways you can do attributes inside of DWG. For this example, we're using extended entity data. And so if I look here, we're reading it from there. And I'm going to just actually show you how I'm going to connect to that thing. So this is a new thing. I'm showing FME 2017. It'll come out in about 2 months' time. And so one of the key features is what we call web as a file system. So if I want to say where I'm going to get this file, look, it says something about BIM 360 there. I say select file from web, browse. Look at that, see, the branding is a little bit wrong there. It says BIM 360, and I can see my connection, go into the theater, and then here's how I pick that file that's sitting up there. If you want to connect to a new one, it uses the fancy three-legged OAuth, as our friends at Autodesk like to say, and I could make a new connection, and I'd walk through here, and I could sign into Lena's account and snoop around in there if I wanted to, but I'm happy with the one that I've got there, that theater. So that's good. And then what I'm doing in this workflow is I'm using these blue things, are what we call transformers in FME. I'm using an extruder, and I'll just take a peek at its parameters, and it's extruding by that height attribute. And then I'm writing to wavefront OBJ because I happen to know that that will be able to be read well by Autodesk. And now I'm using this BIM 360 uploader, or the A360 uploader. I'm saying upload a file from that spot in my temp directory where I just put it. So I'm going to go ahead and run this. And so it's pulling the file down from BIM 360. It's doing the extrusion. It's writing out to OBJ, and then it uploaded it, and I see we're all lit up green. And so if I go back, I could actually click on that. I'm going to go back into BIM 360 with any luck whatsoever inside of here. This is sort of risky. Yes, the theater is there, and I'm very relieved to see that. And now I can use the fancy viewer. And there it is. And look at that design that Lena's come up with. Isn't that wonderful? So I don't think many of you would actually use that specific workflow, but it gives you a sense of what the future holds, where we can interact and work with data that's up in BIM 360, pull it down, rearrange it, do work on it, and put it back. And we're very excited about where that future goes. But in the short term, so we just did that. Yeah, we wanted to go from that to that, and FME was the answer. And that was how we did it. Transitioning to another thing that might be a little more practical in the short term, and that is validation of CAD data. In your experience, Lena, is there ever bad CAD data?
It usually is somehow bad.
There's more bad than good.
Yeah, it doesn't mean that it's bad for you, but when you decide to do another task, you might happen to find out that it's bad for that task.
Right. And so over the years, we've helped many, many customers put into place automated QA processes against CAD data. And so for the example I'm going to show here, we're going to look at a CAD file that, that might have a few things wrong with it or a very minimal thing, and a spec that someone has put together of the valid layers. So really somebody has told me, hey Dale, these are the layers, all these things starting with V that I expect to be in this file. If there's anything else that's wrong, I don't want to see it, or I want to get I want to get a CAD file with only the wrong things so I can send it back to the technicians and say, this stuff is wrong, please reference that in and get rid of it. And so the output I'm expecting is going to be a CAD file with just any layers that aren't in my list. So let's take a peek here. Over in Excel, ahead of time, I've got the list of valid layers. And the good thing about the way I've set this one up is that the person who ends up using this workflow, they don't need to know FME, they just need to know to use Excel, because if we add a new layer, let's just do one into the spec, let's say that V, or let me see, CCO Y DHP. So if that happened, if they do that and save that file, they've now updated the QA test, because what I'm going to do is actually reference that thing. So let's go back here and show how I would make such a workflow. I'm going to go and add a reader first. I'm going to read from DWG, and FME has quite a pile of formats. I'm going to just pick from the file system here, and this Dunlop file is the one I'm working with, and I'm going to say to just read it all in one merged thing. So all the data is going to come through here. I'm not splitting it out by layer. And they're all going to know the FME feature type is the layer. And so now I'm going to go from here to a database joiner. I'm going to treat Excel as if it's a database. And if I walk through this thing, I have it pre-configured. I saved my defaults. So I'm saying go to Microsoft Excel, validate there. I can pick which sheet. Sure, it's sheet 1, and we're going to join the layer name to the valid layers. And then I'm saying it must match 0 or 1 when it's doing that match. And so I say OK to that. And so the things that are going to come out of the unjoined are really the things that are bad, because they did not find a match in that spec. So I'm going to add a writer here, and I'm going to go to DWG, and I'm going to just put this in temp errors.dwg, and I'm going to say that I want to do this in a dynamic way. That means it's going to pick up the layers automatically. So there's my output, and I'm going to connect this up. There we go. And so now I'm going to run this, and I should be doing QA. So I can see from the numbers that went by that I read 26 entities from my input. 22 of them were fine, and I'm actually ignoring the things that are fine, and 4 of them were bad. And so if I go here and I just take a quick peek using my FME Data Inspector viewing tool, let's make this guy a little bit bigger. Okay, so there is the stuff. It looks like they got some stray annotation on a layer called chord text. And so then I would send this back to my CAD technician and have them get their act back together. So that's the solution. Very, very simple. It was well below Don Murray, my business partner's threshold of 10 transformers. I only used 1 to do this. Now you can do far more sophisticated QA looking at geometry. There's a geometry validator. There's attribute validators where we could say we need specific things there or not, but I just wanted to give a sense of that. Now that's all fine and good, but how do I leverage that? How do I, if I make that setup, how do I let others use that without necessarily knowing how to use the workbench tool I was showing or all of FME? And so here's the problem. Let's get our contractors to validate CAD files against a spec. And so I'm going to have some input files that I think might be good or bad, and I'm going to go to a web page and actually do this validation. And I'm just going to click here with any luck. There we go. And this is running one of those workspaces that I just showed before, but out in FME Cloud. So let's go to my Finder, handy dandy Finder, and validate online. And I've got some bad data here. So let's just drag it on here. And magically, somewhere up in Amazon, it just ran, and it's given me a report here of all the things that are bad. And in fact, I can even download those things in a DWG file. And just to prove that we're not completely negative, it's safe, I also have a good file that has nothing wrong with it. Drop that on there, and it says happy news. It actually added these features into a database. And I was thinking on the drive in this morning, in the modern world, what you could do is a front end like this, and instead of going into a database like Oracle Spatial, it could just move this file into BIM 360. So we could do some complicated checks. I could make sure that Lena had put heights on all of her building footprint parts, and if she didn't, it would bounce it back to her. If she did, in it goes into BIM 360, and then I can run my workflow and do my extrusions. And so that's what we wanted to show there. So let's go back to our show. There we go. So how did we pull this off? It was FME Server, which is the automated hands-free part of FME that can be purchased, that accepts workspaces and rules and data flows that we author on the desktop using Workbench and runs them in response to input. It can be scheduled, it can be from a web form, it can be when an email comes in, that kind of thing. And all of that was running on FME Cloud. And the particular demo I just showed is sitting on demos.fmeserver.com. And if we go there, you can see them all and play with them. And actually, all of these have the source code, the rules, and the web pages. There isn't actually any code. It's just a workspace and some web pages there for you to learn from. So that's how we did it. And I think with that, I'm done kind of the intro, looking at a few different ways. And now I'll hand it over to Lena, who will take us through some examples, digging into some more GIS and AutoCAD workflows. Remember, all these things don't involve her writing code. They involve her creating workspaces, and all of them could be automated and run over thousands of files using FME Server or hands-free in response to some sort of stimulus from the outside world. So with that, Lena, take it away.
Yes, I've taken it. Let's take a look at the probably most popular scenario. It's transformer GIS data into CAD, and in our case, we will be working with AutoCAD. First of all, what's the difference between GIS data and CAD data? Understanding this difference will help us understand what we need to do to transform the data from one format into another. So on the surface, GIS data is usually a bunch of geometries with attributes, while in CAD data, usually it's geometries without any user attributes. GIS data can consist of quite smart objects. They might even be aware of their relationships. For example, a line can be part of the boundary of two different objects, two adjacent objects. The other thing, the other difference that I would like to mention is that GIS data is more dynamic than the CAD data is. Quite often, attributes in CAD data, we have attributes-driven symbology, which means that we can do thematic mapping based on attribute values linked to the geometries. While in CAD data, geometries usually have predefined symbology, like color, line weight, etc. Also, in GIS data, labels are usually dynamic objects. They also can be based on attribute values. While in CAD data, labels are independent text objects. The real life is not that black and white. There are GIS data with predefined symbology, for example, in MapInfo and some other systems. And some CAD data can have attributes attached, for example, extended entity data in AutoCAD. But let's talk about basic, more popular scenario now. This is an example of real life data, and we can actually take a look at it as it is rather than on screenshots. So we have some water pipes, Vancouver water pipes with valves and fire hydrant data. And the source format is a geodatabase. We know that there are some attributes attached to all of these objects, and we can see them in table view. Also, we see them as a thematic map. These styles are based on the attributes attached to the object. For example, we know that we have some abundant water mains, and they are displayed in red. We have some active, and we have proposed, and so on. We also have different types of control valves, but as a matter of fact, all of them on the map are the same. They're air gaps. At any point, we can change the display. For example, we might want to display abundant as, let's say, something darker. And our display changes. And if we go back to the slide, this is what we would like to get. We would like to transfer this data into AutoCAD. Let's open FME and try to do this data transformation. So on the left side, first thing that we do, we read our data in. And I will not add this data, but I'll just show you because it's a big geodatabase. And it has quite a lot of feature classes. We just need a few of them, only 3 of them. So we have them already read in. The next step is we are reading pipes, water mains, we are reading hydrants, and we are reading control valves. As we discussed before, we would need to assign some kind of symbology to all of these objects so that in AutoCAD we can look at them and understand some of their attributes. Let's take a look at the water mains first. We have a transformer that is called a DWG styler that helps you style the object. For example, we might want to assign different colors to the water mains, and we can do this based on conditions. For example, if the life cycle status of the pipe is abundant, we will display it in red. If the type of the pipe is distribution, we will display it in blue, and if it's a transmission line, we will display it in other blue. The same, we can set the line type, or we can set the weight. The same, we do it based on conditional values. If the diameter is below 200, then it will be this line weight. If it's between 200 and 900, it will be this, and etc. We also have some point objects. In AutoCAD, it would make sense to display them with blocks. And this can be done using DWG styler as well. The block definitions are taken from the template file, so we choose the template file, and we get access to all blocks that are predefined in the template, and we select the ones that we would like to use. Another step is we discussed that we might want to have some labels, and probably we would like to have control valve diameter added as a label. And in AutoCAD, it has to be displayed with text object. So we can create this text object. We will replace every point with a text, and we will also style it. Let's try to run this translation. And it probably will not run because I have the file open.
Well, it looks like you got away with it.
Yes, I was fast enough. Or it was nice to me, it let me close before it started.
There's nothing quite as exciting as watching a translation, all these numbers going by. It's like a symphony unfolding in front of our eyes.
It is, and it gives you an idea how much features are processed, and it actually helps you a lot with the QA. If you see that at some step you're losing features, maybe you should look at exactly that step, at exactly that transformer, and find out why you're losing those features. So it's very helpful information. The translation, as you can see, was successful. So now let's try to look at the file that we wrote. This is our data. This is what we wrote. We wrote these pipes. As you can see, they have a different line weight. We wrote some blocks. We added some labels. The labels might be not that beautiful. Obviously, what we've done, we replaced every point that represents a valve with a text, and then we added a little bit of an offset. So basically, all of them are moved in the same direction, which in areas with lots of those labels will not look nice. In FME, you can use another transformer. We were using the simple label replacer, but there is a much more advanced transformer. It's called Map Text Labeler. And you see how easy it is to add a new transformer. You have an idea what it might be doing or how it might be called. You start typing, and FME offers you a list of possible choices. I will show you a screenshot with these transformer settings. Just need to move. This is it. So this was the label replacer parameters dialog, and you see you only have access to what to use as a label and how big the label is supposed to be and how it can be rotated. But this is rules for the map text labeler. Map text labeler can work with different types of objects. It can place labels for lines, it can place labels for areas, and it can place labels for point objects. In our case, it's point object. So we can decide what will be our first choice of placement, what will be the second choice of placement, whether we will allow to reduce the size of the label, how far they should be moved, and so on. So this will be, it's an extra cost plugin, but in case you need really create really a lot of good-looking labels, this is your choice for sure.
Yeah, it's amazingly sophisticated labeling engine, and I think that it's probably a little bit undersold. In fact, if anyone is interested in our webinar archive, and maybe I'll put Stephanie on the spot and ask her to text that out, but we would have a complete webinar that someone that you know, I think, someone named Dimitri, someone you may have heard of, her husband put together a couple of years ago showing all the different ins and outs of the map text labeler. And especially for GIS to CAD, it is a killer thing. It's a shame to have people paid out there manually making CAD labels, we think.
I cannot even imagine, by now I cannot imagine placing all those hundreds and thousands of labels manually anymore.
Yeah.
Being a cartographer, it's quite a change in the thinking about how life should be.
Yeah.
So the next step, what we might want to do with our CAD data? Quite likely we would want to print it, and for printing, AutoCAD has a concept of layouts. Layouts are basically your printing sheets. They consist of they have some kind of paper size. It's the size of your output printing. They have some kind of title block with probably text added to them. In our case, the texts are City of Vancouver, date of printing, and so on. And the main part of the layout is a viewport. The layout can have one or several viewports. What is a viewport? Viewport is basically your look at your data, at your model space. It knows the center of where the center of this viewport on the model space is, basically where it's looking at. And it knows what the scale of the printed data should be. It is okay probably to create one single layout manually, but imagine the situation when you have the whole city of Vancouver and you need to split it into dozens and dozens and dozens of sheets before printing. That's quite a tedious job to do. Now you can try to do this with FME. Let's open a more advanced workspace.
So this is going to make the layout. So it's the same one, but there's some other stuff in here that's going to do the layouting part.
Yes.
Oh, these viewports.
This is exactly the upper part of it. It doesn't fit on my screen anymore.
It's the same as before.
Yes, this is the same as before. However, we added some extra transformers. So what we need to do to have a layout ready to be printed, we need to place a title block, which is AutoCAD block predefined in your template. And we need to do some styling of that block. And we need to add some labels to it. We probably want to have a name of the layout. We want to have some kind of title. In our case, it's Vancouver Waterlines and City of Vancouver. We definitely should have a scale mentioned. This is all depends on your title block definition. Then we need, for every layout, we need a viewport. While title block is kind of the same for every layout, it takes most of the layout space and it's placed in the center. The viewport will be different for every layout because it will be looking at the different parts of your model space. So what we need to do, first of all, we are reading an extra data set in, and it's Vancouver facets. It's a bunch of frames that split Vancouver area into
different areas in Vancouver.
Yes.
So basically, you're going to make a CAD file with one set of data and then a bunch of viewports, one for every interesting part of Vancouver, ready to be printed.
Yes, and we need for viewports, we need to create several attributes, and we need to set their values.
Yeah.
I must admit this looks overwhelming.
Yes.
But you can always refer to knowledge base.
Right, because setting it, this is a little more advanced to kind of create all this stuff on the fly, but I'm told, and I'm sure that you're going to show us, that our fancy knowledge center with a bunch of how-to kinds of articles has something about making layouts.
It does.
How about that? The top hit.
This is it. This is the article written by Dave, and Dave is answering questions today. And it describes the process. And it also has a demo workspace attached.
Yes.
You can use it, and you can download it, and you can copy-paste a part that is creating the viewport and title block.
Yeah.
So let's try to run this workspace.
So you're going to read from GIS. You're going to do some fancy labeling. You're going to make these viewports. And then I bet we're going to have to look at it in AutoCAD to kind of have any good result.
But we will try not to open before it's finished writing, because that will definitely create...
We will serve no wine before it's time, or CAD file. Okay. So a bunch of stuff rolls by.
I would say it's quite fast for creating all that data and all the layouts. This is how many layouts.
Oh, so the regions are numbered like M whatever?
Yes, it's what
M whatever, okay.
The names in the data set were.
Okay.
And these are
wow.
All the different ones.
I'm not really a CAD person, but that seems impressive to me. If you had to make this manually, it must be a lot of work.
I would say so.
Yes. Wow, that's pretty good. Now, some folks have asked questions. They asked, are these labels CAD text or M text? There's different kinds of text in AutoCAD, and I believe you can do whatever you want. We can support either of them, and there's settings to do that. So that's a really good thing to know. And can you make multicolored DXF blocks? And I think the answer is yes.
We can.
We can do that as well. So that's a good question. And some folks have asked, well, Map 3D already can read and write different formats. How is this different? And that was asked early on in the thing, and we hope that you see the level of sophistication and customization is what differentiates this approach from the stock, let's just read a shapefile and bring it in to the CAD. You would not produce layouts and so on automatically using the built-in tools.
I would say what you see in this orange bookmark and red bookmark, this would be
Yes.
identical to import with AutoCAD map.
Yes.
Everything you see in between, this is data transformation that you cannot do while simply importing.
That's the magic.
And this is the magic, and this is
Yeah.
a very simple workflow. It's really that small.
Yeah, yeah. Actually, it fits Dawn's rule, I think, of 10 transformers. I think we're close anyway. So now, some people said that's all great going from GIS to CAD, but can you go the other way?
Yes, we can. And let's take a look. Let's try to go through this part really fast. We have input as a CAD data, and we would like to create as an output some GIS data. Let's take a look at these screenshots. Looking at them, we understand what these screenshots are about. For example, the middle one, definitely these are parcels, and we can say that in the middle we have parcel ID, so this really middle parcel has parcel ID 4. On the right screenshot, these are elevation lines, and the middle one has elevation 4, probably meters. And these at the bottom, the lower screenshot, these are labels. They probably are the length of these lines. But when we look closer to this data, we understand that we were able to interpret it because we are humans. We assume when we look at something. To be CAD data, GIS data has much stricter requirements. It needs to be good enough to be queried and analyzed. And for this, we really need to be the parcels to be area objects. And we cannot have elevation line with gap in the middle and to have its elevation as a totally not related text object that sits somewhere on the top of it visually. So these are our challenges. And one more of this, we look at this, the lower screenshot, and we understand that this, for example, the middle label is 13.58. As a matter of fact, it's 5 labels. It's 1, 3, dot, 5, and 8.
Oh, that's a shame.
That's a shame. That happened. Something happened to the data. It was probably converted back and forth, and that happened to it. And this is totally not acceptable for GIS data.
What we say it's safe is that data happens.
Data happens. Let's take a closer look at this data. We will look at it in AutoCAD, but first I had to really use Data Inspector to add a little bit of color so that you can understand. We actually have lines as boundaries. We have parcel lines, we have block boundaries as lines, we have some kind of labels that are parcel IDs, and we have block IDs. And we would like to create blocks and parcels and assign some IDs to them. On the right, this is what we want to get.
A nice, beautiful GIS data set that's well behaved.
Yes. This is the data.
Beautiful CAD data.
Looks good, just not really easily usable in GIS.
Yeah, and so again, you could import this directly into your GIS, or sorry, into Map 3D, but now you're going to have to do a bunch of work to try to make all that stuff into intelligent GIS data. So let's see what you're going to do instead.
Let's look at it really fast so that there is more time for other things. When we were looking at it closer, we realized that the borders were not snapped together, and so we had to do some topology cleanup. Then we had to separate those. We had to snap all of them together, block boundaries and parcel boundaries. Then we had to use block boundaries to create polygons, which are blocks, and we had to use both block boundaries and parcel boundaries to create parcel polygons. Then we read also 2 AutoCAD layers. One consists of block annotations, and another consists of parcel annotations. And there are no attributes at this moment, but we have a text object, which means that we can access text string and create a user attribute based on this text string. And then we were finding a spatial overlap between the text object and the polygon. And if the text object happened to be within the polygon, we were using it as a source for the attribute. And
so that's yeah, spatially we're overlaying the points into the polygons you made.
Yes. And this is what we've got. It takes a while to start ArcMap. Okay, while it's starting, let's take a look. We can see this on the screenshot as well. This is the workspace, and just to give you an idea how the real workspace quite often looks like.
Right. So they often get more than 10 transformers.
Yes, quite often it is. But again, there is help. You can do it yourself. You can ask for assistance with that.
Yeah, we have live chat on our website, and there's a very good community at that knowledge.safe.com, and actually many did ArcMap come up yet? There it is.
No, it's not. Yes,
there it is. Yeah.
This is our data in ArcMap.
Right. So it's a great, proper GIS data set now, and you can see the attribute table there with the parcel IDs and things. The example that Lena showed, really the very beginning of Safe Software was going CAD to GIS, forming polygons, taking text that was contained, adding it on, and then joining to databases and creating a good GIS data set. We've started doing that 23 years ago. It was a lot harder back then than what Lena just showed you, but there's a lot of power that can be had with that.
It's still needed. It's
still needed after all these years. So I think with that, we'll get Stephanie to hand it back to me. Very well done, Lena. Both CAD to GIS as well as GIS to CAD, FME providing very, very rich tools for that. I think in our usage stats, DWG is always the #2 format, both coming and going. Shape actually is the #1 format, both coming and going, but it is always great to see how this evolves and can be very, very useful and productive for our customers. So we've taken a look so far. Let's just recap. We've looked at pure AutoCAD. We've seen how we can go in and out of GIS. We talked a little bit about Map 3D and object data. Now we'll kick into an actual customer case involving Civil 3D, and Civil 3D includes Map 3D object data in it, and so that's both in play for this situation. So for many years, in fact, Regan was looking with me. We started working with some of these customers, Andrew in particular, back in 2009. So it's been a long time that we've been working on finding ways to import the actual Civil 3D objects into GIS and allow that to be controlled and customized. And so there's been an effort in British Columbia, here where we live, called the MMCD, and it's the Municipal Master. Boy, I had it memorized and I forgot. So I apologize, I don't remember but it's a standard that is has been developed through a large group of the municipalities, where they would impose this standard upon the developers submitting drawings and proposals to them, and that allows very easy import and further integration with the various business systems of the municipalities downstream. And in particular, the city of Burnaby has gone a long way in terms of streamlining and automating the processing of these submissions. And so you can see here a number of the things that the city of Burnaby does with this once they get these submissions in. And so this standard is a data model that requires a whole set of fields to be filled out and in the data that's sent in. And so this uses the Map 3D object data parts that are, or functionality that's part of Civil 3D, and so that the files that are prepared by contractors using that can have a very rich set of attributes in them. And very key to this is standardization of the feature names, of the attribute names, of the values, the domains, and it would be very straightforward to create an online checking service that would double check that all of these rules were followed before the submission would be accepted. And so that's what the city of Burnaby has set up some workflows that take these things and create good, useful outputs. And so in particular, this is a typical kind of drawing that would be submitted. that shows some waterworks happening, and then using a couple of FME processes, they can create both a KML as well as a spreadsheet of the assets that were created. And this KML and the spreadsheet can then be shared with other departments, particularly the business folks over in their facility. So if I look at this, let me just grab this one here as an example of a piece of data that has some civil data in it. So if I drag this on, and instead of saying, I'm going to read it as just pure DWG, boy, that's a Freudian slip. I'm going to read it as Civil 3D, and we'll just go ahead and read that. And this is the true civil objects. And so those of you that are civil folks will know what to make of these things. So we can look a bit more at the tables here. So if I look, for example, at the pipes, that's the alignments I was seeing there. But the pipes have more interesting attributes in them that can be harvested out and worked with as well. There'd be site information here and other things as well. So that's just showing you that we can fish out all of the detailed civil information. Now, someone actually in the chat asked if we can read surfaces from civil. The sad news is we cannot read surfaces today, but if you have Civil 3D, you can export from Civil 3D to Land XML, and then we can read the surfaces that way. That said, if surfaces are important to you, please let us know, and we will up that in our priority list. I don't know actually if there's anything on ideas on the knowledge.safe.com ideas exchange for. I might ask you to just check, Lena, while we're working for reading surfaces from Civil 3D, but that would be a great kind of thing to do there. And so anyway, the kinds of output that can be created. We didn't talk much about KML, but Herman Louie over at City of Burnaby passed this along to us. This is an example of something they would send across from a submission to some of their business folks that then shows inside of Google Earth what is going on. And so here's all the different layers that have been created, or tables, and you can go and click on something and see the properties right in there. And this allows people that aren't GIS or CAD people to get a better understanding of the data. And so we'll just get rid of that. And lastly, the other example is of course the resulting Excel. And we didn't actually show much about that, but you can do powerful things going from CAD to Excel. Now, when we started all those years ago, I wouldn't have imagined that would be a thing to go from CAD to Excel. But here I brought in that very one of their workspace or their CAD files, and I've added, using my writer, I just added an Excel writer here, and I had set it up to just copy everything straight across. Now we could adjust the schema if we didn't like this. We can go in here and start to fiddle with the formatting. Let's say that the asset key, I could, make it a nice bold font. I could set up basically a fairly fancy Excel report. And actually, have you worked with Excel output in FME some?
Yep.
Yeah, it's pretty powerful.
It's getting, yes, within probably last year or so.
Yes. If some of you haven't used it for a while, it's definitely worth checking out. And so I can just take a quick look at the kind of output I get from this. And again, it's what could be more exciting than an Excel spreadsheet? Someone said that Excel is the shapefile of business data. It's very ubiquitous, and something as well that's worth running QA on. Turns out there's actually a lot of bad Excel files out there as well. But this is an example of what was created by just dumping that was map 3D object data that was in a civil diagram to Excel. So let's go back to the presentation. So yes, this is the kind of thing we get. Again, I renamed the sheets when they were in Excel instead of having those scary names, but you can do anything you want. So I want to just point out and thank Andrew Walther for working with us so patiently all these years. He's worked with a number of municipalities that have implemented this kind of thing and is certainly available for consulting. His website's listed there. And hats off to Herman Louie, who's been a real pioneer and pushed this stuff, and as far as I know is the leading adopter and realizing the most benefit from this whole initiative so far in British Columbia. And as Andrew says, it's all about the data, and in particular the governance of the data, and automated tools like FME can impose some order in the otherwise kind of Wild West that can be CAD files. Just to finish up today then, we'll switch gears and talk briefly about Revit. We do not read Revit natively with FME, so we cannot read .rvt files ourselves, but what we can do is bring in an extract from Revit and take it to a wide host of things. So in the BIM world, people have gone to Minecraft with FME, Excel again, SketchUp, different GIS. It's actually a reasonably common thing to go from Revit into ArcGIS for routing and those sorts of purposes. And so that particular scenario where we're going to take floor plans from BIM, from Revit into GIS for routing, we start with the building model, looks like the left-hand side in Revit. We want to get the right-hand side inside of ArcGIS. And it turns out it's not that hard to do. But what we have to do first is inside Revit, we use this FME Exporter that is now there. You can install that. It's downloadable from our site. You bring up your model, you click that, and then you can get your extract and do something or get it out so that FME can then read it and work with it afterwards. And we ship with quite a number of different configurations for that. And actually, I'm just going to go into Workbench here. I'll just show you that if we add a reader that was a Revit one, which reads these RVZ files that we produce, not RVT ones, in here we provide you a list of, there they are, a list of different configurations. So if you know you just want the spaces, which is sort of the envelopes of the rooms, we can extract that, or the floor plans, or the envelope of the whole building. These are different things within a GIS context that you might want. And we make it easy. We've pre-baked those configurations in. And so in our case, what we have done to get just the floor plans was using that the building floor plan extraction. And so I don't have ArcGIS on my computer. I've actually been using a Mac this whole time, for those that didn't notice, and FME does run on a Mac, but not ArcGIS. And so for that, I will duck into an extract of this that I had made yesterday of the floor plans, and let me go out into here and drag this. Whoops. Let me just get file open here. Okay, let's open this and space that out and go here. And let's go visit those floor plans out of there, and I'll just bring them up. And this is just going to show us what would be available to the GIS after coming from that 3D Revit model in this particular case. So we've got some of the decorations, but if I go and turn stuff off and say, you know what, I only want the doors, and so the doors are kind of there with their arcs, and every Revit model has got toilets in it, and so we always want those. We wouldn't need to keep them. The staircases, sorry, the spaces that are in the building, and the staircases, but the walls are what are useful to kind of divide it up. So you can bring these features into the GIS and then start doing things with them. On the spaces side, if I bring up their attribute table, you can start to see some of the various parts of the spaces that are there, and we can see the story that they're on. Let me just make this wider. Yeah, that this is on level 3 and so on there. So anyway, that's what we have coming from Revit. In the future, BIM 360 allows API access into the guts of models. And so I can imagine that we may be able to point at A360 and pull pieces of buildings down directly from there without actually dealing with file translations or exports at all. And so if that's something to be of interest to you, please chime in and let us know. So I think we've only got a few minutes left, but I think we're ready to summarize. How would you interpret this diagram, Lena?
I love this puppy.
Who is this puppy?
It's probably the representation of a happy customer with all the problems solved.
With all the problems solved.
Hopefully all the problems solved.
I'm a Canadian, so I'm reminded of The Littlest Hobo. I don't know if any, you do know The Littlest Hobo? You weren't in Canada in the 80s?
No.
And had to watch really low quality Canadian television. There's almost no dialogue. the dog just seems to do all these things, and it's a great show for calming you down.
Oh, okay.
So that would be the littlest hobo. I'm sure would be very, very happy if he could solve and bring all these different Autodesk products together and solve problems. And so that's what I hope we've given you a taste of today. There are a number of fantastic resources, and these will be sent out to you afterwards when you get these slides. You can click on these things, but Map Text Labeler to dig in, a lot of value can be had from the Map Text Labeler when going from GIS into CAD. Very sophisticated labeling, very, very highly tuned labeling can be done. That is an extra cost item. It doesn't come with FME, but we worked with the folks that make map text to provide a great value for those that need that functionality. The layouts article Lena pointed out already. I did a blog on Autodesk University wondering about the tsunami of change washing over us all. I think that desktop products are going to be with us for a while, but they're going to cohabitate with increasingly powerful and amazingly functional web products as well. And I hope you've enjoyed seeing some of that here today.
And speaking about the resources, we mentioned that there are articles and you can submit your idea. There is no idea submitted or user request to support Civil 3D surfaces yet.
Okay.
So whatever you are interested in, please let us know. It helps us decide what the highest priorities for us are.
Yeah, you go to knowledge.safe.com and then you go into ideas. And if you want to see, here's all the ones that are suggested, sorted by voting popularity. PDF Reader, the revision control thing, we actually have the guts of that in-house, so I wouldn't be surprised. FME Home Edition, that's something we're working on. So this gives you a sense of what the highest vote getters are. These are the things that are in beta right now. If you were shipping FME 2016, that is a wonderfully stable, good product, but the things that are in FME 2017 are listed here. We have got quite a lot of the ideas that were suggested have made it into there. And these are the ones that we've done since the beginning of time, and ironically bringing back help, the #1 thing. So yes, Rollo, we did do that. But you can page through here to see the things that we have done. And there's at least 4 pages worth of your ideas that we have done since the beginning of time. So let me go back to there. Just to finally wrap up, we're going to be inviting the world here to Vancouver in May for our User Conference 2017. But ahead of that, we're going to invite you to experience the magic of transformation in 60-some cities around the world where we're doing one-day stops. 21 or so of those are in North America. I personally will be at 5 or 6 of them. Looking forward to doing that. And you can register very soon. And for both of these, if you have a story to share, we'd love to have you share it with us. So with that, I think we're out of time. So we're going to say goodbye. We'll hang around to look at a few questions if people want to interact with us in the panel. But and we've also got Regan and Dave standing by. But thanks, everyone, for tuning in. We appreciate you sharing your time with us today. So from snowy and, well, it's not snowy. It's frosty and clear, Surrey, British Columbia. This is Dale Lutz saying goodbye.
And Lena Bach saying goodbye, too.
Okay.
Thank you.
Thanks so much. Now we'll just take a little last bit of time to take a peek if there's any last questions here, just before we say goodbye to everybody. Let's see. Anything? People are asking how we deal with pipes. We represent pipes by their center lines. Can Land XML go into Esri? Yes, the Land XML reader can do it. Oh. How do you take parcel data in Autodesk that is bad and align it to GIS data parcels to correct and move? So you can use, what would you say would be some tricks? So you've got a good GIS file, you've got some sketchy CAD data, you want to kind of line it up.
We will probably find out some partial overlaps, analyze the percentage of the overlap, maybe try to snap vertices.
Yeah.
Do stuff like that.
Snapper overlays, there's the neighbor finder. We do work with the folks at MRF. They have some good tools in their cleaning that can move data around as well. So that's extra cost item, but the MRF tools would be worth looking at. Are we going to send people the workspaces? You betcha. Lena, did you use FME 2017 or 20?
Yes, 2017. Everything was done. Even though it's beta,
yeah.
It's stable beta. It's working fine.
And thank you, Caesar, for pointing out that it's master municipal construction documents. I knew that, and I forgot. So thank you, and apologies to my friends Herman and Andrew for forgetting that. Yes, you can get a trial version if you want to, and just go to safe.com/downloads probably, or trial.
It's easy to find.
Yeah, it should be.
I think it's downloads.
Ask the free chat people. Hey, Herman Louie has a fan that says he's awesome. We think so too. Thanks, Herman. You do have fans out there. IFC stuff. Can we read or write 2, 3, or 4? And the claim is that we do. Can we write directly to Revit? We cannot right now. So let's see. Somebody remembers Littlest Hobo? Maybe tomorrow I'll want to settle down. Until tomorrow I'll just keep moving on. That was the sad song at the end. The Littlest Hobo would ride off.
I know what I'm doing at lunch today.
Yeah, but I think they're all on YouTube.
Oh,
I wouldn't be surprised. And they were filmed in they were filmed like low quality, so they were probably digital, so they have a funny look to them. So anyway, thanks for reminding me about the Littlest Hobo. And let's see. Anything else? Let's see. Let's see. Thanks very much, someone says. And they want the workspaces, and that's good. A few Swedes that joined us, people from Austria, thank you very much. And let's see. City of Cold Lake. I don't know. We'll have to get back to Stan. I don't honestly know if Cold Lake is a customer, but Stan,
I believe they are.
Yeah, okay. You think you've worked with them before? Yeah, so there should be some FME going on there, and so therefore there would be possible to create. There are some local FME groups in a few places. I know Denver has a very active one, and we've supported them, and a lot of different companies have FME groups within them. I know CAE has an FME group that meets weekly to swap resources. And someone's asking if we're going to India. I know that there will be an FME World Tour stop in India. At least I was told that there was, but I don't know who from SAFE is going, but someone will be going. I know our friend SRG will be involved there, a long-time FMEer, probably one of the experts, certainly in India, on FME technology. Hey, someone from Switzerland joined in, so thanks for joining. And let's see. What else do we want to... some people are applying for jobs here, which is actually always a good thing. We are hiring in your group, the experts group. And
it's honestly, it's a wonderful place to work.
Well, thank you, Lena. And hey, did my Tesla have any trouble starting? Not a bit. In fact, it's like riding a curling rock down a hill. That's what I'd say riding a Tesla's like.
Okay.
It's kind of heavy, and if you have the right spin, you get to where you want to go to. No, it actually handles really well on the ice, but you do have to be aware that you're sitting on top of 5,000 pounds. So
you kind of have to feel one thing with it.
Yes, you feel as one with it, but it was fine. Can you get the mail of SRG? Yes, we'll just hang on. We'll send you that in a second. Latesh will get the mail of SRG, and so I think we're pretty much it. Unless Dave or Regan, do you have anything you want to chime in with? Your silence will be assumed as nothing.
Maybe just a short comment about the city of Cold Lake. Please contact us, and we will try to get you in touch with somebody who's working with FME in the city of Cold Lake. So
yeah, so use the live chat and be in touch around the city of Cold Lake. And Latesh, just hang on. When we shut down the screen sharing, I'll send you SRG's email address, and you can be in touch with him over in India. And I think with that, I think it's the recording. Yes.
Will be sent.
That's right. So our technician Stephanie has had multiple machines recording this, so we will for sure have a recording, and usually it's out within the day, and then you can listen to this and play it back in slow motion. Oh, I think that's probably it. All right. Now we really will say goodbye.
Goodbye.
Okay. Take care. I'm going to stop the webinar now, but I will actually keep it going. How do I stop the screen sharing? Stop the screen sharing, and we'll say goodbye, and I'll answer Litesh. All right. I think our audio is still live. We'll actually shut that off too. Okay. Goodbye, everybody. This is the last words, like Ferris Bueller would say. You can go home now. The movie's over.
Yeah. Goodbye.
Goodbye. Until tomorrow, the whole world is my home.